Okay, so my name is Michelle, and I was given the task to research tall oil applications and its impacts. I was paired with Dr. Trajano, who works at the University of British Columbia. And so to first start off my presentation, I want to explain what tall oil is. So right now, it's a current waste product that is being burned that is from the craft pulping process, which is essentially the paper making process. And so if we look at the diagram I have here on the right, it just goes over how paper is made through the whole craft pulping process. So it starts off with some wood chips that are put through different machinery, like the digester that's full of thin liquor, and then through another machine that removes oxygen, and then the last machine that removes lignin, which is just a strong fiber in the wood. And so then we are left with a pulp, which can be used for different paper products like toilet paper or cardboard or printer paper. And tall oil is derived directly from black liquor, which is produced from the evaporation of thin liquor. And that tall oil is composed of wood molecules and unreacted thin liquor, which is often called white liquor, that contains the rosin acids and fatty acids that I have here on the left. So to further look into this topic, my mentor gave me 4 questions to focus my research around. So my first question was to look into how much tall oil is readily available globally. And to that, I found that there is around 2.5 to 2.6 million tons available globally. And to find that, I used the University of British Columbia's library database called Web of Science and Google Scholar. And so most of the articles I found agreed around the number 2.5 to 2.6 million tons. And here towards the bottom, I just have a few information about like how tall oil is currently being used. So on to the next question, which is focusing on how tall oil is kind of separated from black liquor. And so I'll just go over a brief overview on how that works. So starting off right here, we have the black liquor that was just mentioned earlier, and that has those fatty acids and rosin acids and lignins and other woody material. And so that is all made into tall oil soap. And so this isn't really the tall oil that can be used in different like fields and stuff. So it has to go through the reactor. And so the reactor is filled with like acids and steam. And so it basically heats up the tall oil soap. And when left overnight, there are 3 layers that form. Hold on. Sorry. Yeah. So the first layer is the crude tall oil that can be used in machines and vehicles. The next layer is the lignin layer. And so that layer composes of 2 different types of lignin. One type being the insoluble lignin, which can be put back into the craft pulping process and produces energy that is formed from the recovery boiler. And the second type of lignin is the emulsion lignin, which can be put through another machine to get any leftover insoluble lignin out. And then our last in the 3 layers is the spent acid, which is just all the unreacted acids from the reactor, which is then put back into the tall oil soap storage. So focusing back to the crude tall oil, this is fine to use for machines and cars, but some places required it to be more distilled. So it would go through the evaporator and more distillation columns, but I won't get into that right now. Okay, so now with answering the question. So current research has not deviated far from the separation process I just explained. So I would give the technology readiness level of that a 9. And so technology readiness level is just a scale from 1 to 9 that shows how prepared and how large scale an idea is. 1 would be the lowest, and that would be something that's just written on paper and researched a couple times. And 9 would be something that you would see in a large plant or facility. And so most papers note additives that can help the separation of black liquor to tall oil, and that can be fatty acids, polymer addition, and alkali alcohol. That can be that. So then we'll move on to the third question, which asks about the transformation and application of tall oil, which I found that most articles talk about tall oil being used as a biofuel. So an example of that is turning tall oil into biodiesel to fuel cars. And another example of possible uses of tall oil is in biochemicals. An example of that is like insect and plant growth regulators. And both of these ideas are 3 to 4 on the technology readiness level scale because they are performed in labs and not really big scale, but it's more than just a research paper. And then my last question focused on how an application of tall oil would work. And for that, I focused on biodiesel because I knew that biodiesel was something that I was interested in looking into. So I compared it to 2 articles, one article by Mackay's and his team, and then another article by Adewale and his team. And they both looked into tall oil being transformed into biodiesel. So the first column I have here, best reported conversion, shows their best reported conversion rate in their article because they both use different methods to transform tall oil into biodiesel. So for Mackay's, he had a 75% conversion. And so, yeah, so he had a 75% conversion, and Adewale had a 97.9% conversion. And so I got in the next column the production based off of these 2 percentages and 100% selectivity, meaning that like nothing would go wrong essentially. And I based that number off of the estimated availability I mentioned earlier, 2.6 million tons. So in order to do that, I just multiplied the best reported conversion times the amount of tall oil available. So for Mackay's, I did 75% times 2.6 million tons, and I got this number right here. And for Adewale, I did 97.9% times 2.6 million tons, and I got this number right here. And so for the column that says percent displacement, for that, I checked to see how these production values of biodiesel would compare to the demand of petroleum diesel. So down at the bottom, I just have a link that shows the amount of biodiesel consumption, not biodiesel, petroleum diesel consumption. And so in order to find this percent displacement, I used the global consumption of diesel and divided it by the production value that was shown in the previous column. And this shows how much it would, if we were to try to replace biodiesel, if we were to try to replace petroleum diesel with biodiesel, this is the percentage we would get. And so in the next 2 columns, I just did the same thing, except I assumed that 90% of the tall oil would convert into biodiesel. And then I divided that by the global consumption in order to get the percent displacement here. So in both of these cases, the percent displacement is very, very low. It is less than 1%. So that's not really a good sign, which shows us that it's not really easy to convince a whole company to switch completely over to tall oil. So that means that research should be more guided towards smaller applications of tall oil and of biodiesel. Like me and my mentor talked about how biodiesel from tall oil is currently just being mixed with petroleum diesel, which is a good use of time. And so that concludes my research portion. And I just wanted to talk about my overall experience with Talaria and research. So the project itself was very intimidating at first because I was just lost. I didn't think I would be able to like look into how tall oil could be used for many different applications. But through the weekly meetings with my mentor, I was able to understand it better. And in those meetings, we talked a lot about engineering and what it means to be an engineer and what you can do with an engineering degree. And it was very useful. So I really appreciate that. And the thing I struggled with the most throughout this program was probably like sitting down to really look through all the articles because there's a lot. It can get very repetitive, especially with the scientific language that a lot of researchers use, can be really intimidating. But I managed to get through it. And I'm really glad that I participated in this program because I think I learned a lot of things that I can apply into future classes and different things in life. So that's about it. Here are my citations for everything that I mentioned, and that's it.